So I think we should be live now. Yeah, now I can see something. All right. And I should mute myself. Here we go. Perfect. It's the same thing I do every time. Hi there, and welcome to another session of the virtual Kotlin user group. I'm so happy you're here. So we already have around 13 to 16 visitors. It's great to see some groundskeeping up front. As always, if you like it, press this thumbs up button somewhere down there. If you haven't done so yet, click the it's abonnieren. It's in German for me. Subscribe is, I think, the name. And if you don't like it, don't leave the thumbs down, but let us know what's going wrong, and so we can fix it. And that is me. So let me welcome Tristan. Hi, Tristan. How are you doing?
Hey. Hi, Holger. Yeah, I'm doing good. Thanks for having me on to give this talk.
Thanks for coming on. I'm really looking forward to this. And so with no further ado, it's your stage. Enjoy.
Brilliant. Okay, thank you. So welcome, everyone. Thanks for attending the talk. This is a talk on a functional approach to exception handling. For those of you who don't know me, my name is Tristan Hamilton. I'm an Android developer at HubSpot. Just been there just about 2 months now. Previously, I was at Workday for about 5 years in a couple of different roles, and I've taken a 3-month hiatus between those 2 roles. I highly recommend doing it. It was fantastic. Got to hang out with these 2 little critters on my back over that time. With the previous versions of this talk, I've usually sort of reduced my persona to some emojis. So here they are again. Yeah, so I'm an avid, I guess, more a collector than player at this point of electronic instruments, whether they're modular synthesizers or just keyboards. So feel free to ping me about that after if you're interested. Love my favorite food right now. I love a good broth, whether it's ramen or pho. It's fantastic stuff. And yeah, this lambda emoji at the end is supposed to represent my keen interest in functional programming. So yeah, if you haven't, let me see, is that working? Yeah. If you haven't sort of taken from the title of this talk, it is definitely going to be a talk about functional programming as well as exception handling. But before we get into that, let's have a look at this repository that I've kind of contributed to in the last year or two now. And I'll just screenshot the description on GitHub, which is Kotlin result is a result monad for modeling success or failure operations. And if you're like me, when the first time you saw all this sort of jargon, you probably thought, okay, what does any of this mean? Well, I'm going to try to sort of reduce some of this down into nice digestible info. And before I kind of get into that, I want to sort of give more reasoning as to why we're talking about exception handling, in particular in the context of functional programming. So exception handling is something we all as Kotlin developers have to do. So I think why this is such a great topic to sort of introduce into the world of functional programming is that it is just a very common subject and it's kind of something that is at least tangible and that you can wrap your head around. So yeah, and I also think that hopefully you'll see with this result type that with solving exception handling in a functional way, that it kind of makes you start to think about how you can compose your programs in general. So yeah, the other main point of kind of introducing result type is to try to pull back this curtain on what I think sometimes is seen as sort of this gatekept subject or of functional programming that you need a degree to understand anything that's going on. And I don't think that's true. I think there's a lot of things in there that are very digestible if presented in a way that I think is something you can actually relate to. So maybe you just want me to show you some code. Let's get right into Kotlin result. Well, I think before I do that, if I was to go straight into it, we might still be left wondering what is some of this jargon that I'm talking about. So before I do that, let's try to go back a little bit and talk about something that if you've ever picked up a intro book on functional programming, you're going to have heard this term thrown around the place, which is referential transparency. So what is referential transparency? Well, I'm going to try to break this down using just simple code examples, and hopefully we'll get a good grasp of what it is from that. So say we have this function add3, quite simple. You pass in an integer, we add 3 to it and return that integer. Now, if we were to assign a val x to this function, say with the parameter 3, well, we could very easily replace that function on the right-hand side with the outputted value, the 6. And essentially, we haven't really changed the execution of, or the behavior of this program, should I say. The execution has changed. We're no longer doing a computation, but it is the same essential behavior. And that is kind of in a nutshell what referential transparency is. It's the idea of being able to replace a function with its output and not have changed the behavior of the program. So with that kind of this little basic example, let's sort of, well, first, why should you care about that? First thing I think why it's cool is that if your functions are all referentially transparent, well, then really nothing is hidden. So you can really kind of take everything about the function that you need to know as a developer from the type signature. You know what it outputs. And with that, I think you can kind of reduce the cognitive load it takes. So you're not needing to worry about, is there some kind of side effect going on? Is there some kind of exceptions being thrown? You kind of can tell everything from what the type signature tells you. And I think with that comes easier testing, because you don't have to worry about anything happening under the hood that you also need to verify or check. But of course, there's a whole world of exception throwing that we do. So let's try to extend on our simple example here. And suppose that we decided that our add3 function should only be allowed to work with positive numbers. So let's update our function now so that if the number is less than 0, well, we're going to throw our custom negative number exception. Let's see, can we still show that this is referentially transparent? Well, if I pass in -3 into add3, how can I represent this? I'm not sure I can. I think because of the fact, at least in what we're being shown, there's nothing handling that exception being thrown. So rather than changing the behavior of the program's just halted. So there's no way to represent that in a line of code here. And thus, the first riddle of working with exception throwing is presented to us. And it does leave us wondering, well, is there a way around this in Kotlin? Is there a way around this in other programming languages too? And in Kotlin's case, you might be familiar with a solution that we can actually find on Jim Carrey's highly disturbing costume here, which is the null safety that Kotlin provides. So there is a way we can solve this now if we took our, say, this add3 function that we want to still have that it only works on positive numbers. And we could say that, well, integer should now be a nullable integer. And with that, we can imagine that we've changed the implementation, that rather than throwing this custom number exception issue, we now just return null if the number is less than 0. So with that, have we kind of solved our referential transparency conundrum? Well, I think so. So now if we have a negative number, we can simply say, well, we can replace that function with the output that's just null. And likewise, with our add3 example that we first saw, we can replace that with 6. So great. I think from that, we can deduce that nullable types support referential transparency. We can also say that using throws or throw is going to break referential transparency, and essentially that exceptions in Kotlin are not checked. Now, I leave the little clean star there because, of course, with Java interrupts, you can have an @throws annotation, but if you're just working purely in Kotlin, there is only runtime exceptions. So that is an issue. And then nullables, we can say that, well, they support referential transparency. Again, something that referential transparency gives us is the type signature tells us everything we need to know, and to sort of reiterate the point that, that should make everything easier to test. So I'm hoping now you're not looking like this already from those couple of examples. I think from here, it might be easier to kind of go into some more real world cases that I've come across in an actual code base, which I think for some can help grasp what I'm talking about here better. Excuse me. So yeah, this is, I'm going to show now a code example from a code base I had previously worked on, where I had decided to go looking for, could I find any examples of referential transparency at play in the code base? And I found this function in a class called new organization info extractor. And what this class did, well, what you can see here in this function is that get validated new organization info, it takes a URI, and then it maybe gives us back some kind of new org info at the end. Looking in this actual function itself, we can see this is just sort of a highlighted bit of the body of that code. We try to get that host itself, and first of all, we look at seeing if it's a valid web address, and that seems to be able to throw several different types of exceptions. And when we catch one of these exceptions, what happens is a toast error is displayed, and then we return null. So we're kind of seeing something similar to our add3 function that we saw at the beginning. So let's have a look and see, is it referentially transparent? Well, say I had this value, my new org info, that I'm trying to assign with this function call, and I'm passing a known bad URI. Well, can I replace the right-hand side with the output? And I think I can. Cool. We were able to say null, but are we missing something? So if you saw in that previous slide, we actually had a toast error displaying in the catch. So there is a side effect happening here. This is something that we're not catching when we replace the value with null. Essentially, we've broken our referential transparency by changing the behavior of the program by replacing the function with the output. So that's a problem. Oh, and just to say that the issue here is sometimes referred to as our function isn't pure. Now, what is a pure function? For some functional programming fanatics, they would say it's the only way to code. It's that all functions should be pure, and that really means that all your functions shouldn't have side effects. Mutable state is bad, essentially, and that any kind of side affecting action is going to break referential transparency. But I'm here to say I am not the proverbial golem holding the one ring that is functional programming, saying that that is something we should do or try to strive for. I think languages like Scala and to some extent Kotlin exist to very much bridge that gap between the OO world and the functional world. And I think what I would advocate for is that, we can look at bringing over some of these functional programming paradigms where they make sense. So we're not always just trying to strive for referential transparency for no reason or for, as sort of some kind of de facto rule, but there's some places where it might benefit us. And you could say that with null safety, is it always the solution here for solving referential transparency? And one thing I think we've definitely lost with that function we just looked at is we're kind of losing all kind of fine-grained failure reasons. All we know is like, well, we passed in some kind of URI, we didn't get what we wanted back, so let's just return null. But I think there are a lot of situations where you do probably want that kind of fine-grained reasoning as to why something failed. And as of right now, in say Kotlin with unchecked exceptions, the only way to, you can't really achieve referential transparency in doing that. So I think we can find a better solution here. And why don't we try and look at our function again and see, can we do this without still getting our fine-grained control, without catching, and also without and while also persisting this referential transparency. So looking at our function again, we're going to see, can we replace the right-hand side here and achieve referential transparency, while also figuring out what this sort of fine-grained exception is. So to do that, we're going to first look at the function type signature again. So straight off the bat, we need to get rid of our nullability, because that's not something we want. Next, we can go look in the actual body of the function again. We know now that we definitely don't want any side effects in here, so that's going to have to go. We're also not going to probably return null anymore. So at least for right now, let's just rethrow whatever this get valid web address is passing in. Yeah, so, and actually even then you can think that why even catch here? We're just rethrowing it anyway. So we can remove this catch block and just say host is equal to get valid web address here, and we'll worry about that, whatever exceptions it throws, a little later. So next, okay, we've kind of reduced that down to a single line of code in terms of the body of that function. Can we replace that function now? Well, I don't think so. All we've really done is propagate the error to this level, and we're really not doing anything with it. So we need to like rethink again how we're going to solve this. To start, I would say let's add some type information to our value. It's a new organization info value is what we want to get back. But we also know now that occasionally this thing, depending on this, if there's a bad URI passed in, we might get back some kind of exception. So ideally, we'd be able to do maybe something like this and define in the type signature that, well, either you're going to get back a new organization info or you're going to get an exception. Now, this is not real Kotlin code. Compiler will say no if you try to do this. This does exist in some languages. So if you're familiar with TypeScript, this is called a union type. And while Kotlin, at least right now, has no intentions, I think, to add this, I'm going to say, who knows? If you've looked at the Kotlin 1.6 milestone 1 release there, they did actually, in addressing a separate issue around having definitely not null generic types, they've added an intersection type, which is kind of like this, except with an ampersand. So the idea, like where this, we can think of this union type as broadening the scope of what the type could be. The ampersand is sort of tightening the net of what that could be. Now, it's a very limited version of it, and it's for that very specific purpose. But I think the fact that they've introduced that syntax could mean perhaps in the future we might see something like that. But for now, let's not hold our breath. So we know this definitely won't work right now, so we're going to need to think of something else. But maybe the fact that we're representing both types in the signature is going to help us. So something we could actually do in Kotlin today is we could use the pair type, and we could describe what this returns perhaps as either an optional of new organization info or an optional of some kind of exception. Now, of course, this would be like super cumbersome if we described it like this, but we can definitely extract from how we've defined this that there is some goodness we can take from this and maybe create a more specific type. So we know that we need some kind of wrapper. We know that we want to describe the success path in this type, and we also know we want to be able to encode the failure as well. And then we'll also need, with whatever new type we come up with, we know we want to be able to assign it both as a successful or construct a successful instance of it, and also a failure instance of it, for us to persist this referential transparency thought exercise we've been carrying out. So if you haven't gleaned yet, there is a solution, and that is result. So yeah, why don't we try to construct our own result type that kind of encapsulates everything that we just looked at with that pair object. So we could have class result with two generic types, v, that is whatever our success object is, and then why don't we just make that the failure case extends from exception. So we could model this then as a algebraic data type. So we have a data class success that holds some value v, and we also have a failure class that holds some kind of error of type exception. We would have it that the success or class extends result with value or nothing in the exception position, and in failure we kind of the reverse of that. And if we were really writing this into our as Kotlin code, we'd probably want to set the generic types as covariant as well. So let's see, can we do this now that we have our results type? Well, first thing, we want to change this type signature to now show that this is a result of either, or well, the success of new organization info or an exception. And inside of the body of that function, we're going to slightly roll back the changes that we introduced. We're still going to have a try catch in here, which, and I know we're saying here no more catching, but at a local level, we will have this catch, but we can talk about this later on. There is kind of ways to abstract this away. And yeah, so here now, when we catch whatever exception get valid web address throws, we're going to just return a result of failure. Okay, and now let's see, have we achieved referential transparency with this function? I believe so. We can now replace the right-hand side with a failure result, and we're also getting the fine-grained exception reasoning here. And in this case, we're supposing that it's some kind of URI syntax exception. So hooray, success, we've done it. Or have we? Again, we're forgetting about our side effect, this toast message. We still want to do that, right? So it does mean we're going to have to handle that in maybe a slightly different way. So let's say we now have assigned our new org info value. Well, we could suppose that we have a side effecting function that we could add to our result class called onFailure. So it will just check if that result is of type error, and then we could handle our toast display inside of that. And we could also add maybe an on-success side effecting function where you can pass a lambda to do whatever happy path you want. And something that some people are probably familiar with if they've worked with other types of functional programming types or wrappers, you're going to see fold around the place. And often result types will encode fold like this, where you can pass two lambdas, one for on success, one for on failure, and handle it this way. Great. So I think with that, we've shown how you can replace nullable types with a result type. We've gained now that our failing results tell us why it failed. So we're getting that kind of fine-grained reasoning. And also we now have referential transparency at the function level, which is, or at least at our get validated org info level, which is great because it means the function should be easier to test. And what I say by type safety here is we're no longer needing to worry about a potential exception leaking out of that local function. So we can kind of trust in the type definition or the type signature that it's of type result. Yeah, so I guess you're thinking, well, perfect. We know everything about result now. There is more to talk about. And you might recall from our initial description that there is this nasty monad word lurking in the title. So I think I'd be doing everyone a disservice if we didn't discuss that a little bit more. I don't want to go into any type of category theory explanations for what monad is. I think you can do a pretty decent job of getting a rough idea of what it is from a developer's standpoint by kind of just going over this very small definition of a monad in Kotlin. So we can think of any type that extends this abstract class to be a monadic type. So, and there's just really three properties that it has to fulfill or uphold to be called a monad. So one is that it needs to be essentially a wrapper type that holds some kind of value here, which is we're calling type A. And you should be able to construct then an instance of this monad in this way. And then you just need two functions. You need a map function that takes as parameter a function that is of the type of what the wrapper is holding here, A, and returns back some kind of type B. And what map will then output is a monad of that type B. And then we also have flat map, which very similar to the map definition, except you'll notice that the lambda that's passed in, rather than returning a type B, now returns a monad of type B, and then we still get output at the end, a monad of type B. That probably is still very like gobbledygook. What am I talking about? we're going to dive in a little bit further into what exactly map and flat map are here. And I think a great way to do that is to steal some pictures from a great blog called Monad in Pictures. I'm going to drop a bunch of, I'll do a link bomb at the end where you can go look at these things yourself. But let's just talk about what map means for a minute. Just going to drink some water. So much talking. So map. We can first think of like, imagine you just have a value 2. And back to our very initial function we saw, add 3. You can quite simply pass that value 2 to our add 3 function and you get out 5 the other side. Well, what happens if we wrap that 2 inside some kind of container or box? Well, if you now try to add 3, you can't do it. Like add 3 only knows how to take integers, doesn't know how to take whatever your 2 is now wrapped inside of. So what we need, what map does for you is it gives you the ability to really just apply your function to this wrapper that you know contains the type you really need. Some kind of magic happens, and at the other side you get your boxed up value with what you wanted to happen all along. So what map is really doing under the hood then is you want to unwrap that value out of the box, apply your function, put it back in the box, and send it on its way. We can look at that in kind of more concrete example of, suppose we had an option monad in Kotlin. It might look something like this, where so you can think of this as very similar to the nullability or Kotlin's null safety here, but just encoded as a type instead. So we have either some that I guess you can think of like the happy path, where you have some value of t that is an option, or you have nothing. And so the map type is, you can think of it as it's kind of encoded along the sum route, or like the happy path. And what's happening here is if you call map on an option that's of type sum, you're going to get the unwrapped t value that it holds, and you can apply some kind of function that outputs some kind of type u, and then it gets wrapped back up in an option. Let's see that in action. So if we had a value x that was assigned sum2, and we tried to call our add3 function we had at the very beginning, it's not going to work. It expects an integer. So we can now map. So we can see here that, I wonder, can I use a pointer? Annotate maybe? Spotlight. Oh, a mess. I don't know what I'm doing here. I'm going to ignore that. So I'll just continue on. I won't have any type of pointer. Yeah, so we can see here that we call map on our sum2, and what happens there is we call a lambda that is being passed that value 2 that's inside sum, and we're able to apply our add3 to it. And you could replace that whole right-hand expression with the output, which would just be sum5. Likewise, if we had assigned none to value x, map is just going to do nothing here. It's going to see, oh, this is of type none, just return this, because there's nothing to be applied. Now let's take another maybe more complex example. Say we added another function now called alphabet, that you pass it some position and you hopefully get back that character position or you hopefully get back the character at that position in the alphabet. Say now we again had our value x assigned to sum2, and you want to now apply alphabet inside of it. Well, we would still again just map to get the value out, apply that to alphabet number, and hopefully what we get at the other end would be some c maybe. But if you recall, alphabet actually returns an option itself, which is, so really what alphabet is giving us back is some c. And then when we map over our sum2 at the beginning, we're actually getting the sum c wrapped in another option. So what if we were to replace that right-hand side expression, you'd really end up with sum c, which is just awful. So we would love if there was some kind of way that we could flatten this down. And of course, that's where flat map enters the scene. How the blog describes that is, you can think of it as a way where if you have some box container containing a value, you could pass it into or you could apply flat map over it. Say we had this function not even, that's going to also return either some value that is not even, or none. Well, what you get back at the other end is just the output from that inner function, really. So you can just kind of think of it as a way to say, hey, as long as my monad that I'm operating on is the same as the output of the monad of the function I'm passing into it, you're still going to get out at the end just whatever that outputted monad from the inner function is. I know I feel like that's kind of hard to wrap around until you sort of see it in action, which I think is easier. But yeah, here you can see the definition of what flat map would look like. For option, you're passing in the unwrapped value t. That function returns an option u, and that's what you get back. You get the option u back again. So updating our example we saw there, we could just switch this to flat map, and what we now get back into value y is just going to be sum c, which is the output from is the monad that's output from alphabet here. So with that, hopefully you now have a rough idea of how map and flat map work. And with that, we'll kind of jump back to our example of how we can use this new org info to operate over the success and failure paths. So imagine now we had a separate function called save org info once you've actually grabbed this new org info. And that's also returning a result as well. Well, in the current syntax that we've seen so far, that would have to occur inside of our on success lambda. And given that save org info also returns a result, we're now seeing that it's going to start to get messy, because we're going to have to fold inside of that function, and soon you're into spaghetti code. So maybe we're going to see the true power of the monad that flat map really brings. And to do that, let's have a look at how we could implement flat map in a result type. So it's kind of similar to what we were looking at with option, where we want to encode flat map into the successful path. We could very much have done it for the exception one. Sometimes you'll see functions written as like flat map error, where you're really just trying to flat map over the error path. But here it makes most sense that we do it for the success value. So here you can see when we call flat map on a result, when it's of type success, we just apply the function with its value that gets passed in, and then that's what gets returned. Otherwise, if it's an error, we just simply return the error. So with that, you can kind of see how we can start to call flat map on results, and you're always going to have the error case available even after multiple flat maps could have occurred. What does that, or I guess then an easier way to wrap your head around that is something that is coined as railway orientated programming. The term first appeared, I believe, in around like 2015 or 2016. Scott Vlashing, an F# developer, I think he coined this phrase, but the idea can be applied across any language really that has monads with flat maps. But what he kind of supposed there was, you can think of error handling as this two-track system, where a function you can think of as a two-part of a track, where it has a success rail and a failure rail, and flat maps are what bind these rails together. So he gives an example of, you take three functions, each of them returns a result, and here you can see it's parse, validate, and send. And what he's doing is, with each one of these functions, he's flat mapping to the next one. So at any point, if one of those results was an error, even though he's still flat mapping across the rest of them, at any point he could access the bad or exception or I guess exception reason or failure reason throughout the results that are returned back. So we can try apply that to our example we were looking at already. First off, let's replace now the code we had seen as new org-info.flatmap, and we're going to pass the save, and we're going to then invoke save org-info inside of it. So what that should mean now is the flat map is going to return back the monad that save org info calls. Otherwise, we're just holding some kind of error. And we can kind of visualize that in the Railroad system, in that the new org info has that happy path, or as soon as we kind of called flat map, there's still the opportunity that we can bridge to the error case in the next rail as well. So right now, this is kind of what our code looks like. We can always handle an error at any point here. So we could add this on failure call to say, well, now if new org info fails or save org info fails, we can present that toast message. Whereas before, we would have had to have had all these nested folds, and each one of them having handled that error case. So now it's kind of in this nice, neat position. We could suppose that on failure here, while it's a side affecting action, still returns the same result you were working with. So we can kind of visualize it like this. It's sort of this bridging side effect piece of code that still carries on the same rail. And then of course we can keep chaining. Then we can say, well, let's add another flat map, ignoring what's happening with that on failure side effect. And now maybe we want to switch tenant once we have that new org info. And that could look something like this. And of course, then as well, we might even want to just start a brand new train track. And maybe we have a function called recover that simply says return some kind of result. And it gives you the option to, this is what happens when you encounter an error. So we could kind of visualize that as now we've started a brand new train track that starts at get known orgs. So yeah, I hope you can see kind of from that how thinking about these result types or monads with flat map kind of gives you a way to be able to chain these operations together in quite a neat way. And if you start to actually put your functions together in such a way that it'll make sense to be able to chain them, I think you can really start to compose your programs in quite a neat way. So yeah, I think with that, we've kind of gotten everything we need to know about result, and we can zoom back to the present. You're now graduated with a full understanding of this description of Kotlin result, which, yeah, as you can tell, is just the implementation of this result type. One difference with the Kotlin result library's implementation you can see here is that it's not constrained to be, the error path is not constrained to be of type exception. So you could use it to really model anything as your failure path. It doesn't necessarily need to extend from Kotlin's exception type. I guess the other thing to note there is success is named OK and failure is error. Yeah. I guess the next bit is like, well, what did I contribute to that? It sounds like it's a pretty complete library. Well, there is one additional kind of thing that you would often see in a lot of languages that provide monadic types or a result type. So say we have this example from before where I'm chaining together a lot of operations that I want to do that are all results. So we flat map, and recover. In this example, you can see that each one of them is just passing the org info on again. That's just what we get back as the success of the result. But imagine now we swap that save org info. It doesn't give back the org info, but it gives back a DB status. And imagine that, so that's what our code is now going to be updated to. And then imagine that switch tenant requires both the org info and this DB status to be able to be invoked. So we're kind of missing some stuff here. So the only way we're going to be able to solve this is to go and start writing nested flat maps, which is where your code can really start to look like spaghetti. And there is a way around this, which is monad comprehensions. So I think the phrase was first around in Haskell maybe, but where I would have seen it is in Scala, and was something that then I expected when I started working with these type of types in other languages. And the implementation we ended up settling on for the Kotlin result library looks like this. So it basically gives you a way to chain your flat map calls together imperatively. Very, I guess, kind of analogous to how once you put stuff inside a coroutine scope, you can call your suspending code in this sort of imperative style. And yeah, so how this works then is when you want some kind of result, you define your binding scope. And then inside of it, any function that usually returns a result now has this extension function on it called bind. And you can see here that each bind call, you can just assign it to a val, and suddenly you have the access to all the values previously without having this sort of nested junk. So you can see here what would happen if, say, get validated org info was successful. You'd get org info, but then maybe save org info binds and you're actually into a failure path. Well, as soon as you encounter a failing bind, you can think of that's the end of that result, and that's what will be assigned into org info. So now we'd be holding in org info an org exception that originated with that save org info function. And yeah, you might think this looks somewhat similar to another library around, which is Arrow. Interestingly, for a while there, before hitting 1.0, they actually had kind of messed around with what the syntax should look like. We ended up with bind when I first went digging around to implement monad comprehensions. I ended up kind of looking at some very early source code of Arrow because I didn't want to add all of the sort of implementation that they had done to handle higher kind of types and stuff. And they actually were originally calling it bind, and now I guess it's come full circle again. And with the 1.0 release, again, now the extension is called bind. So that's just a little history of that. So yeah, once we added that to Kotlin result, we actually got a request that, oh, it would be great if this worked in a suspending context. So that was the first request that came in. So we made it work for that. But then I realized, oh, actually it would be good if it also worked if you tried to call it inside of a launched or async coroutine. So what actually is happening now under the hood in this example is as soon as one of these async coroutine binds fail, the other coroutine children will actually be killed. Now, that doesn't mean necessarily it'll kill at that exact moment, but it does mean they're all going to get canceled. So it can be kind of a nice way to potentially save on resources. It'll also work with launch, but I think using this with launch is kind of getting away from the sort of referential transparent creed here, in that, you know, that it would still work. It could be a nice way to be able to kill some other or cancel some other running coroutine once a bind is encountered in another one, but it will work. So yeah, that was kind of cool. We added that to it as well. And yeah, with that, I guess we can kind of summarize up what you gain about using this result type. Well, we now can see that using a result, you get to model success and failure of a function. That can give you referential transparency. And it also gives you sort of fine-grained failure reasons for whatever your code is doing. You're able to write your code in such a way that you don't need to be worrying about your code perhaps throwing exceptions. You've kind of found a workaround for not having checked exceptions available to you. And hopefully it should mean you're able to write simpler tests, and that you know everything you need to know in the type signature, and you can replace the right-hand side with some kind of output value. The second part then is, if you do choose to use a result type that is a monad, because of course there are many result, or there are some result implementations that you wouldn't call like a monadic type. I think from that, you certainly get composability once you start using flat map and monad comprehensions. This is maybe a little more subjective. I think if it's a monadic type, you can gain readability if you use it in a good way. And I think once you start to think about and work with everything as results or monads, you can really start to, your reasoning speed, I think, can really increase for an overall program structure, as you kind of can, how these different paths and things are chained together. But it wouldn't be fair to not also mention some of the downsides of maybe using a result type. As I mentioned as well, I don't think it works, or it's something that you need to implement everywhere. There's a time and a place where using a result type makes a lot of sense, particularly where you want that kind of fine-grained exception control or fine-grained error flows. So yeah, but with it definitely comes a learning curve, because a lot of the libraries out there that implement it you kind of want to have a pre-existing knowledge of the meta language that we covered a little bit with map and flat map, but it's things that you'll see across all of these container types and monads and streams. But it's definitely becoming more common because I think most people have worked with RX or now with coroutines and flows, and you'll see a lot of these operators across all of them. It is another dependency if you decide to choose Kotlin result or arrow or something like that. If you're already dependent on RX, importing something like this, you might already be able to achieve with it. So you might be able to just reuse existing RX types for something like this because it'll already have the kind of monadic operations that you want. It does impose a coding style. I think that's something as well to consider. Like, if you introduce new people into your code base and they see, oh, what's all this like binding stuff and flat map and chaining, that's definitely, it's an added learning curve. I've also seen this talked about, like that results or coding with results, you could kind of think of it as analogous to exceptions for flow control anti-pattern. So this is where you're kind of dependent on experiencing a function throwing an exception to handle some specific happy path code flow, which I think maybe you could say that's the case, but when you consider that results are very explicit and that when you have a type signature with result coming back, you have to handle or that you can handle both cases. It's not something that's sort of hidden in an exception that might be thrown from a function. Again, due to the fact that there's no checked exceptions in Kotlin. So and then finally, maintenance. I think this was something I thought was interesting to mention, that if you're using nullability across your app for something similar to this, like the initial examples we saw for referential transparency, if you decided that you didn't want something null anymore, it'd be quite easy to just remove that null from the function, and I think the rest of your code should continue working. Of course, if you decide to replace a function type with a result, you may need to go and update quite a lot of call sites for that to handle what is now a result instead. Have to address this elephant in the room because there has been some issues that were recently posted to the Kotlin result repo, and previously I would have just discounted it because it wasn't exposed in the public APIs. You had to know this magic compiler flag incantation to actually get Kotlin's own internal result type exposed on functions. It was there. You could call run catching, and you could operate over results that were returned from run catching, but you couldn't define your own functions that had a result type in them without using this flag. So since 1.5, they've done away with that. You can now just use result itself. Why not just use that? Well, I think based on what the talk I've just given and what we'll kind of just have a look at the keep proposal that is I think basically finalized now, and maybe they'll add more in the future if they decide to change it. But the proposal really has a lot of the reasoning as to why it's pretty much separate from using something like the Kotlin result or arrows and monadic types. And you can kind of sum that up with, there's two sections that I just took some quotes from. One of them is that the result class is not designed to represent domain-specific error conditions. So immediately that is kind of saying, it's not for fine-grained exceptions, which is what we kind of talked about as one of the big values of having a result type, I personally think anyway. And sort of leading on from that, then they actually specify that, and this is a slightly adapted quote, libraries that promote railway-oriented programming style with monads and their transformations heavily rely on functions returning results, etc. This programming style can be implemented and used in Kotlin via libraries. However, core Kotlin language and standard library are designed around a direct programming style in mind. The general approach in Kotlin is that alternative programming styles should be provided as third-party libraries and DSLs. So what they're really saying there is, yes, if you want to avail of railway-oriented programming, which is what I think I'm trying to advocate for here in particular situations, that they do think you should use a separate library. This is their Kotlin result type is just simply not for that. So we can kind of summarize Kotlin, the Kotlin team's stance on exception handling as, exceptions aren't checked. You better catch if you throw them. Result run catching is kind of a blunt tool. if you need fine-grained exception policies, then model your domain results accordingly, whether that's with a third-party library or using nullables as we initially saw, or some kind of like sealed data classes. And this is one thing I added actually because I thought it was kind of interesting. In the future, this is a little bit of speculation, perhaps we're going to see a typed Coeffect system as a sort of alternative for exception handling. Why do I say that? Well, if any of you have been looking at the context receivers proposal that I think is now in kind of a finalized state, there's definitely an open issue at the moment on the Keep repo where you can now comment on the sort of finalized proposal, and loads of interesting comments in there. But there's one very interesting section in the actual proposal called Algebraic effects and Coeffects. And what it talks about is, well, first, just a very high level overview. The idea of context receivers is to basically support context dependent declarations in Kotlin. So they're going to introduce this keyword called context, and you'll be able to, in addition to extension functions, now be able to say, okay, if this function is within this context, it only works if you're with that context to use it. And they have a separate section in the doc where they're talking about algebraic effects and coeffects, and they mentioned that very brief or high level overview that like an effect is like a mechanism in some programming languages to model various effects that a function can have on its environment. And you can really think of that as some languages have figured out a way to encode in your types side effects. And what they're saying is that while they don't plan to do that in the language, they may enable that through these context receivers. So there is a little example that they give that I've kind of adapted to show how maybe that could work. So you can see here we have a functional interface, exception handler scope. And here I've just written a function called log that takes some kind of exception. And say we had this extension on integer called add3, we could add a context exception handler scope. And inside of it, we're still going to just return null if it's less than 0. But for the exception itself, we're actually just going to call that log function that's now exposed due to the context it's in. And you can see then in the main call then, when we can only invoke that add3 on an integer when you're within the scope of it. And because it's a functional interface, we can just define it in line there, and we pass what the log function is. So you can see there, it's kind of it's a bit of a bridge in between. It's not exactly giving us referential transparency as to what it does, but it gives us a way to kind of get around the fact that we don't have checked exceptions in Kotlin. And of course, this is very speculative, so I'm only going on what the example they showed in that key proposal. So yeah, I would recommend going and having a read because it's very interesting. Yeah, definitely can't talk about all this functional programming in Kotlin without mentioning Arrow at least. Yeah, if you haven't seen, Arrow just got a big milestone of a 1.0.0 release. I highly recommend going and checking it out. The only thing I'll say is, if you're looking for just specifically a result type, I think Kotlin result is going to do that perfectly. If you're looking for the whole toolbox, Arrow is great. They've got monadic types for lots of things, and they all have these monadic comprehensions implemented as well. So yeah, pretty cool library. I thought I'd also mention something on the performance. So when I did implement binding initially, I added a binding module, or not a binding one, a benchmark module using Kotlin X benchmark. It's still it's only like on the 0.3 release now, but it uses Java micro benchmark harness underneath. And I was able to write some, perhaps contrived, maybe someone on this, watching this can come along and check out the repo and see is there a better way to implement the benchmark test I did. But you can see here that there's a little overhead to using the binding keyword over in the library. They tend to use and then instead of flat map, but they're analogous to each other. But yeah, you can see here that binding, you take a little hit using binding over the standard chaining. I actually had done several back a while ago, some benchmarking against Arrow's implementation of binding with the either type. And it was coming out with like really, and this was like around the 0.10x release, something like that. And the operations per millisecond was like super low. And I thought, oh, it's just like crap. Like the performance is, there's just too much overhead with the reflection stuff they were doing. I think with like higher kind of types. I think a lot of that's gone now anyway. But what I think I've come to the conclusion of is once I added the coroutines implementation of binding, when I tried to do some benchmarking tests on that, that also came out super low, pretty much the exact same as what the Arrow implementation was doing. So now I'm not sure if it's just like the overhead of using coroutines for implementing binding, which is how Arrow does it. They use like these low-level coroutine continuations. It's a pretty cool approach to it. But yeah, so I'm not sure if it's actually just a case of that the JMH benchmarking tool just doesn't know how to, or it's not going to give like accurate outputs for when you're using coroutines, or whether it actually is the coroutine overhead. But just thought I'd mention that, and that could actually be a potential pull request if someone wanted to go on to Kotlin result and look at the benchmarking module and see if we can add some accurate benchmarks between that library and say Arrow's implementation of them. Yeah, and to sort of summarize everything then, well, what did we learn today? I think a lot. Hope I didn't go over too much, but we learned about referential transparency. Just to reiterate that, it's the ability to be able to replace a function with its output and not change a program's behavior. We now learned about encoding exceptional behavior into a type signature. We've learned about monads and the power of flat map. We've looked at the general concept of a result type and how that ties into railway oriented programming or oriented programming. We looked at a little briefly at the Kotlin result library and its monad comprehension implementation and how they're the best one. We looked at some of the downsides to the approach of using a result type. And then we also saw how, kind of gave an explanation as to why I believe Kotlin's own result type is not entirely conducive with the paradigms that we were looking at today. And also had a kind of speculative look into the future of exception handling in Kotlin. What did we not learn? Well, we didn't talk about how you could categorize and organize your errors into like these domain-specific models. There's a great talk from Kotlin Conf 19 called Error Handling Strategies, which kind of delves into that and touches on a lot of points that I was talking about today, which I'd recommend checking out. Excuse me. We didn't really look at alternatives to using a result type, but I think, you know, the focus of this talk was a functional approach to exception handling. So I'm not going to talk about those others. Yeah, and then of course, we didn't really dive into anything else in the vast scope of what encapsulates, I guess, functional programming in general. So, you know, we didn't look at like implementations of collections as this sort of recursive thing. We didn't talk about higher kind of types, and we didn't talk about modeling effects or encoding effects into our type signatures, which is often referred to as like effects or IL. So they're all other subjects that you could probably devote many hours and many talks to, which I won't go into. I believe Arrow probably has a lot of good presentations on a lot of the libraries they already have that can handle those things. So I'd recommend checking them out as well. Where to from here? Well, please go and check out the Kotlin -result or -result library. I actually, when I had to update this slide, I was shocked to see that the previous screenshot I'd taken, it was only at like 200 stars, and in about a year, it's managed to climb to 500. So that's kind of a cool little milestone that happened in the last few days. So good on Michael Bull. And if you want to learn more, I'm going to do a big resource dump into the Kotlin virtual Kotlin user group Slack channel. So you can go explore lots of stuff that I've touched on in this and more. And got to do a obligatory, we're hiring. So yeah, HubSpot is looking for great Android and iOS engineers. The main office is Dublin, but you can work fully remote from any location that has like a HubSpot entity. So right now, I guess this is more of an EU audience. That means France, Germany, Belgium, UK are all places you can work fully remote from. And if you are interested in that, you maybe want to work with me, you can reach out to our director, Aidan Siney at asiney@hubspot.com. And with that, I'll say thank you for listening to me, and we can try to do a Q&A now. And also, if afterwards you have more questions, please, if you're not already on it, join up the Kotlin Lang Slack and go to VKUG and leave your questions. Thanks.
Awesome stuff, thank you. And once you drop the links, I will make sure that they find their way to the description of the video as well. So they are here and in Slack, and then nothing can go wrong anymore. Perfect. So we did have 2 questions so far. The first one goes way back to the beginning. And in the midst of it all is his username. Asked, wouldn't it throw in an exception and not return? This was in the context of you presenting referential transparency and changing from throw to null, I think.
Maybe we can go back here and take a look. Do you know which slide this was?
I think it was somewhere around here. Not concrete. There's a slight delay, so I'm not 100% sure which slide it was. So I'm not quite sure.
I guess maybe it's in relation to. I didn't show the implementation of this, but the idea would be that you'd remove the throw. Like there'd be no more throw. You'd get rid of the throw of that number exception and just return null. At least in this case, but perhaps I'm completely off with where they're referencing.
Yeah, that was fine. So I would suggest in the midst of it all, sorry, we can't directly go into the topic, but maybe you can ping Tristan on Slack and ask him again, and then I'm pretty sure you will find the. I keep on watching over there. He's not sitting there. Here's the camera. Sorry. And I hope you can find the spot you had your question around. The other question is, now I can look over here from Rock. In a MVVM plus use case project, Android, for example, on which layers would you use this pattern? Repository, use case, view model, view?
That's a good question. And actually, that's something I hadn't plugged as well, but we did the Kotlin dash result. Another reason to use that implementation is that just about, I'd say 6 months ago, we've fully ported it to be multi-platform support. So I think it targets most of the targets anyway. Certainly iOS and Android at this point. But yeah, I think it would probably be at the repository or use case level is where I would imagine that you'd want to be using the result type. Maybe it's at the repository and you can handle your results cases there before pushing it out from that layer. But yeah, that's one thing I'll say, actually. Most of the places I've seen this used have been in backend projects. So I actually haven't seen it used that much for a front-end project, but I do know there is the guys at Cova, they're a UK insurance kind of startup. They one of their developers, he wrote a cool post on using Kotlin result inside of their Android project. So that might be a cool place to follow up, and I'll post that afterwards.
Awesome. And this actually answered the last question I had, which was around multi-platform. So it's good to hear it's already there. Yes. And out of curiosity, how much work was it? Because it doesn't look like it has a lot of impact on different platforms, but it might not appear every time.
That's a good question. It actually wasn't that hard at all, to be honest. The only thing, if I recall, that was that I had to do was we were using, I think I ended up writing like an expect for a particular type of exception. And I think it was because, whatever way I'd written it, what I was extending from wasn't available on all platforms. So if you go check out the code, you'll probably find there's a few folders like in the iOS one where there might be an actual implementation of just like exception, so something like that, or some kind of particular customized exception. And I think that's pretty much it. Just had to include that for a few folders and add the targets into the Gradle file. And other than that, I think we were able to compile and do it. Yeah, the only challenge was actually when we were going to try to produce an iOS target was Michael Bull had the keys for the project. So, and he didn't have a MacBook locally, so we didn't have any type of simulator to actually test this out. So I was like testing it locally, seeing if it worked, and I'd be like, okay, it should work. We should be able to publish that now. And then we ended up switching to it's escaping me now what the name of the GitHub CI pipeline is, but yeah, there is you can choose a machine on that specifically for publishing your iOS targets, and it has your Xcode already installed and everything. So yeah.
All right. Cool. Really nice to hear. So let's see, there were a few more comments. Tobias Price asks if you could add the keep numbers to the link list and all the slides.
Definitely will. Yeah.
Awesome.
I'll have all those in the little resource thing I'll post.
Perfect. So I think that's it for today. Thank you so much for your talk. There are two more things. One thing is Nicholas Frankel asked me to mention Kotlin Dev Day, which is a hybrid event happening in Amsterdam on November 25th. So if you're interested in, go to kotlindevday.com. I will put this one into the description as well. Also, feel free to catch up with Nicholas on the Kotlin Slack. And similar to this, I am happy to be the co-organizer of the Java event this year again. And we are looking for contributions, so everything JVM related, and I'm thinking of Kotlin related stuff here, would be highly welcome. So it's a digital event calendar, 24 nice little JVM related treats from the 1st of December until the 24th of December. And we even have 2 IntelliJ licenses to raffle just among the authors. The rest will be announced later. Let's say it this way. And that's it from my side. Tristan, any famous last words?
Nothing. Thank you for having me. It was great. See everybody.
Perfect. Thank you so much. Have a good one. Enjoy your evenings, folks. And that's